Testing, testing, testing. Hi, good morning, Mahesh. Good morning. Hold on, because I'm testing something. Let me stop again. Share, include models. Okay. Oh, sorry. Okay, good morning, Mahesh. So, um, based on my own record, we stopped at the slide 19. Yeah. I promise I just do online recording sections so that we do not need to do the replacement class. Yeah. This is because the tomorrow, Tuesday, I have the exam proctoring duty. Yeah, morning and then afternoon. Yeah, two sections. So, wow, quite tough. So I hope these recording sections will sufficient. Um, if it's not, then we try to figure out how to let you catch up back the progress. Okay, so we are still in chapter one, the introduction and the basic. So this is ICT 279. So we stop at this slide 19, which is, as I mentioned, we're trying to balancing the CIA trial. All right. So yeah, before I continue, right, I just want to let you know, I won't be make completely 2 hours. Yeah. So I will just try to finish up the this chapter one, and then if okay, I will touch a bit on the tutorial, the lab. Okay, let's see how. So let's start. So we have total 61 slides. So I start from 20. So I need about 40 lah, 40 to 41 slides. So non-reputation. So as I mentioned to you, so isn't it? I mean, sorry. So even though this not one of the core principle, but actually, if you're asking myself, it is closely related and is often specifically mentions. So non-reputation provide the proof of a person identity linked to some activities. So can be used to prevent individual from denying what their action they have done. All right. So commonly used with the credit card. If you buy something with credit card and sign a receipt, right, you cannot later deny making that purchase. Yeah. So the signature used to reputate me if I deny making purchase. Something like the audit lah. Okay. I believe I mentioned it verbally to you. Non-reputation is something like you cannot deny on the activity you have done. Yeah. So it used to prevent entity from denying they took on an action. Like for example, here is like using digital signature to verify someone sent a message. If I will send you an email, so that is signed by my digital signature, you know, and can be proof that I sent it. So digital signature is something like in your email header. So that also cannot be not 100% bulletproof. If someone want to spoof it, also can, but it's harder. It's a bit harder. So logging activity in the active audit log. This is also quite common. Like not only in the system and also on the application level. So everything is logged. When you log in, when you log out. Even though our browser also like that. So they track and then they see what browser you view and so on. But of course, it's your personal laptop. After he track for your cookies, for your sessions, for your browsing history, you still can able to delete it. But if it's in a corporate machine, you cannot. Okay, so we don't usually use the corporate machine um, for the personal activities. Yeah, just hold on. Let me just have a look again. Okay, the mic is on, recording is on. Yeah. Yeah. Okay. So, okay, auditing accountability on the OS level, audit log, okay, record security relevant events. Remember I show you the system log, application log, and then the user log, yeah, in the OS. So user identity associated to this event. If link between the user identity and the user can be established, user can have accountability, responsibility lah, something like that. So audit tool must be selectively kept and then protected. Why? If you keep track everything, right, you need to have a lot of the storage. So it's good that you selectively keep, yeah. So that action affected the security can be tracked based on the responsible party. Okay, so this one is the same picture, attack surface. So he used for the car. So what is the attack surface for this car? So you can see there's a lot. Yeah, using Bluetooth, using Wi-Fi, yeah, using internet. Yeah, some your engine mechanical things also can be hijacked. Yeah, radio also can be hijacked. Brake system also can be hijacked. Yeah, your door system can be hijacked because now everything is keyless. Most of the expensive cars and so on. So all these things give a highly level entry point for the attacker. Yeah. So fundamental design decision. So where to focus on the security control. So remember earlier we talked about the balancing. Yeah, balancing the CIA. Yeah, you have to balance the confidentiality, integrity, and then availability. So here he talked about focus maybe on the data, if data is very important for you, or the operation, if the process is very important for you, or the user, your user is important. So which one you want to focus? Example, account database, format and the content of the data. So internal consistencies. So example, like account balance is fluid. So operation that may be performed on the data items such as credit, debit, transfer. Yeah, you have to use float, right? Yeah, the decimal place. Then who can be allowed to access the data item? Like, are you given access to who? Uh, when you do your diploma assignment, you didn't spell clearly, but when you work outside, you have to spell clearly on all these access. Yeah, account holder, the clerk, who can access. Yeah, so this is the layers example. Yeah, remember when we do for the enterprise architecture. Yeah, so of course this is not tied to any specific vendor or researcher methodology or the research approach. This is just a general. The lowest one is the hardware, and then you have your system level operating system, system level software, yeah, kernel, and then operating system, your services, and then your application to the user. Yeah. So which layer you want to give the security mechanism? So remember the onion. Some people also draw like the onion. Yeah, better to think of layers as a concentric protection ring. Mechanism toward the center are more generic, while mechanism outside are more likely to address individual user requirement. Okay. If you can attack my application, is fine, but don't let him go further. If you already know, right? If your OS is screwed up, no matter what application you run on top of it, you just cannot do it, right? So, or you just destroy my hardware. You put water onto your motherboard. Do you still can run the application or OS? No. Yeah. So the outer layer is more, you know, more likely address individual user requirement. Then the more inside one is the more generic. But however, if any failure on your hardware, basically you screw up. Yeah, because it's more important. So next, complexity or assurance. Yeah. So often location and security mechanism related to complexity, like generic mechanism are high assurance. Betul tak? Just now I told you the hardware. Application involves security function. Yeah. So generic, specific on the data. Yeah. You try to find a way to understand this term. Yeah. So machine oriented hardware just now. Human oriented is more on the application level already. Specific. Is this complex? Yeah, because you need to, depend what kind of the programming you need to write. Yeah, and then focus on the user. But however, your hardware, do you deal with you? No. The manufacturer already said what to do, how to deal with the voltage, how to deal with the temperature, how to deal with the more machine-oriented kind of uh, questions and mechanism. Yeah, simplicity and higher assurance or feature-rich security environment? Question mark. What you want to achieve? So dilemma here. Simple generic mechanism may not match specific requirement, but do choose right feature from rich menu. You have to be security expert. That's why system analyst is coming into the place. Yeah, another subject. So they have to decide. They have to talk to the user. Um, what do you want to achieve? Yeah, remember we agree, right? There is no 100% secure um, software or hardware and so on. Okay, security control also need to be enforced within the given domain. So here is another aspect, which is centralized or decentralized control. Having single entity in charge make it easier to achieve uniformity and assurance, but it also make the center entity become a bottleneck. Remember the star topology? Yeah, the thing and the middle one, if it's destroyed, then become a single point of failure. Distributed architecture are efficient, but also have to take care to guarantee that different components work together. You can have a lot of the leaders, a lot of the manager, a lot of the distributor, but is it easy to control? No. And the money you needed to invest to all these higher processing machine, you need to have more lah. Yeah, instead of just one, you need to have more. Yeah, can understand, huh? So blocking access to layer below. So every protections mechanism defines security parameters. Part of the system can malfunction without compromised security or outside parameter, untrusted. Uh, Part of the system can be disabled, can disable mechanism lie within the parameter, trusted. So that is untrusted and trusted. Yeah. So can I say the untrusted one is your cable connect to your monitor, connect to your mouse? Yeah. Attack from outside are more common. Attack from inside are more dangerous. So attack from inside is referred to your kernel, your OS, and so on. But don't you think that they also attack from outside? Then slowly they evaluated the privilege, then go to inside, from outside go inside. Yeah, how to stop the attacker from getting access to the layer below your protection mechanism thing. So sometimes like web, remember the web, the normal attacker just deface your website or maybe do some SQL injection on your web, your login page. That's all. Then slowly from there, they do their lateral movement, right? Slowly go into your database. Then from the database, trying to get the admin, and then see whether can go in and go in and go in and go deeper and deeper. So, do you do anything to prevent this happen? So this is the question asked. Layer below examples, recovering tools like restore data by reading this directly and then restoring file structure. So circumvents logical access control, like recovery tools, like if you're gonna ransomware, you only can restore the data, right? I believe this is what a lot of people doing it. Yeah. So we don't deal with the hackers for the ransom to pay the ransom. Yeah. Physical access, yeah, both from the attacker media and bypass the OS control. This is sometimes you watch a lot of the Hollywood movie or something, right? They just put something on and then tap, and then they can bypass everything, like take over your control. The movie it show more, more interesting lah. But how to do is you need to have more skills. Yeah. Backup, the same story. You need to have backup. Your backup can be offline or can be online on the cloud and so on. Side channel analysis. So this term is something new to you, yeah, side channel analysis. So which means cryptographic key material never leave smart card, but power analysis may reveal it. So it means also like you need to do few more round on the cryptography, decode and code, yeah, until you see the plain text and so on. Okay, theory first, a lot terminology. Yeah, so this chapter one basically is like putting in too many things inside. Yeah, we try. Yeah, we try. Security system. Security system is not just a computer package. It also requires security conscious personnel who respect procedure and their role in the system. What is the weakest link? Human. Remember I mentioned you give a 2 million project, useless if your administrator or your system analyst or whoever person in charge just careless, then breach already. Yeah. Conversely, good security system should not rely on all personnel having security activities. Okay. Yeah, we should have a more advanced, more intuitive, more reliable system. Yeah. So this is the message here lah. So dilemma. Security unaware user has specific security and requirement, but no security expert, so can't understand the security evaluation. True. Yeah. Imagine you put a business analyst to take care of this IDS, IPS, and firewall. They are IT person, but they are not the security expert. So, but the security expert maybe cannot talk to the user. So work together lah, work everyone together hand in hand. Yeah. So security system component, three fundamental component: reference monitor, access control concept that refer to abstract machine that mediate all access to the object by subject. Reference monitor. So if you have the sys internal tools, yeah, maybe you can have a look this reference monitor. Here it's just a concept. Yeah. Security canal is like a hardware, firmware, software element of trusted computing base that implement reference monitor concept. Yeah. TCP, trusted computing base, totality of protection mechanism within computing system responsible for enforcing security policy, including hardware, firmware, and software, but also physical location, procedure, etc. Yeah. So this term maybe you heard before. Yeah, you heard. But then I don't know how to show you in a physical way. But one thing I come across is like the sys internal. Remember I told you the sys internal, the tooling. Yeah, maybe from there you can have a look. Yeah, especially for the reference monitor. It gives you the abstract of the machine. Yeah. Can we go through first, okay? Theory first, yeah, theory first. So hardware security rationale. Usually security is placed in one of the lower security system layer. Typically make it possible to evaluate security to higher level of assurance. Putting the security mechanism into the core of the system reduce the performance overhead caused by the security check. Yeah. If you put everything too secure, that is also a problem. It will causing the overhead because it's need to do so many things. Yeah. Minimize layer below issue, your hardware bottleneck, your RAM, your CPU, and a lot. Yeah, the hardware things. So balance it up, balance it. TPM, hardware component that can be used to provide authenticated boot, preventing modification of low-level software or use of unsupported software, remote attestation, cryptographically verified configuration information, encryption, key generation, CSRNG, protected storage. So all these things are already you have already one. It's just that whether we have go to that level of the knowledge or not. TPM, Trusted Platform Module. You can Google some Microsoft. Yeah, Microsoft Trusted Platform Module also can. Yeah, understand the theoretically the concept first. Or I believe you've heard this before. Yeah. So Trusted Platform Module. Yeah. Reference monitor. This topic can be very, very technical, but actually this we trying to be more theories. Reference monitor can be placed in hardware, something to monitor. A reporter monitoring, yeah. Operating system kernel, this is common. This hardware model CPU. Services layer, less common, but exists like Java interpreter. Yeah. Your Java need an interpreter, need a compiler. Yeah. And then application not really used, but too limited. So this reference monitor at where? Your hardware, your OS. Okay. So hardware architecture recap. So CPU, register, and ALU, arithmetic logic unit to execute the instruction given in machine level language. So your memory is your RAM, your ROM, yeah, read access memory, right? Read only memory, right? Then EPROM and WROM. So more and more newer lah, okay? Bus connecting CPU and the memory. Yeah, instruction come to your CPU. The CPU put the thing into the temporarily working place called memory first. Then only you do the work, and then after that you give back to the CPU. Then you give to the output. Yeah, input come from mouse, keyboard. Output can be the storage or the monitor and so on. How to process in your memory? Yeah, correct. So I/O, keyboard, mouse, hard disk, network, cable, whatever. Process versus threat. Yeah, treats. Yeah. So process is a program, it's a software, it's a program lah, program better lah. In execution, consisting of executable code, data, and executions context, work in its own address space and can communicate with other processes only through primitive provided by the operating system. Treats are strands of the execution within process. So all treats share process address space, thereby avoiding overheat of full context switch, but also avoiding control by security mechanism. One process can have a lot of the threads. So I don't know whether you still remember or not, because I really um talk about this in the sys internal tools. Let me see whether I can uh quickly um I try, let me see I can quickly show you or not. Yeah, so this is the process explorer. Yeah, process explorer. So you can see the handle DLL, the treats. So like this is what I have opening. Like for example, what is the easier one that I can show to you? Maybe you see I opening so many browser of the Chrome. Okay, this is handle, this is DLL, this is thread. One each of the tab are opening, so he has his treats, yeah, to treats to open. So why? He help the process. Yeah, he divided the job, like everyone do a little bit lah. Yeah, so what else is it? I open Foxic. Foxic also got. Yeah. So if you are, this is MSH also I'm opening. Yeah, so you can see so many things he's doing. Is it got any reference monitor? I remember got um how suddenly if you want me to find, I can't. Wait, let me just trying to see is that sys internet reference monitor process monitor. We use the word process monitor process monitor. Let me see. Process monitor. Yeah, he need admin. So which one is the reference? Okay. I mean, I am a so-called uh GUI guy lah, not that technical lah. So I need to see yeah, I believe all this system detail, system tree. Yeah, this is kind of like the reference monitor already. Yeah. So I mean, see if I can have this MST. Is it something more simple? Later my machine is hang. I worry because it's keep on searching, keep on um doing the job at the back. Yeah. If I right click this, I like include process name. Let me see. Filter. This is all the MS team. And what else is he doing? What? And to session detail. No. This is my. Dude, this is my detail, man. So okay, so you have to explore a little bit, yeah. So remember, this internal is your friend for all the developer, for the engineer, IT support. This internal got 160, I think 160 or 150. The tools, the tiny tools you can use. Let me just do first, otherwise it will be crazy, man. My yeah. So I heard many lecturers say lah, if you got chance to study computer science, then you will go deeper on the operating system, go more deeper on the operating system architecture. If you're an IT student, you okay, kind of okay, not that deep. Yeah, so theory is good. Yeah. So integrity, if you still remember, whatever the modification need to be reported, yeah, in a way. So in terms of the operating system also, two requirement, user must be able to give operating system to invoke. User must not be able to misuse operating system. We need to give flexibility to the user. Yes. Yeah. User friendliness ma. However, we cannot let the user to sit on top of the on your head lah. Yeah, cannot let them misuse because they are not the architect. So usually like your phone also, if you want the developer privilege, you need to do a lot of the thing kind of like a hidden. Yeah, only the one with the skill they can doing it. Yeah, last time a lot of people go to jailbreak lah, to get the administrative or more access. OS also the same, but now I think the OS is also control very tight. So I also never do overclocking or jailbreak anymore. I'm just use whatever is provided because we want to maintain the integrity in your system. So they are achieved via the mode of the operation or control invocation. Note that this mechanism can be disabled if attacker get access to the lower layer. Yes. So the hacker want to come in to do all these things. So mode of the operation, in the dual mode operation, a system can work in user mode, aka protected mode, where instructions that are not critical for security may be performed. You can I mean this, let me recall back in we want to boot the operating system in the safe mode lah, something like that. And if you know some code, you can go inside the supervisor mode of the operating system. Yeah. So I seldom do anymore. Yeah, but I think in the past, Windows 98, Windows XP, Windows 7, I still practice a little bit. I don't know whether you, Mahesh, you know all these things or not. Yeah. So supervisor mode, so you can now monitor root system mode. Privileged instruction are instructions that can be executed in the supervisor mode. So bits in the code selector CS register in the CPU record current mode at the hardware level, current privilege CPL. So depend your diploma how deep your operating system go. So or just the theory level. So for me it's theory level. So we learn a bit like just now the diagram, a basic diagram like this. Of course, then in the CPU, you learn some of the registrar, if you register, if you still remember. Yeah. So control invocations, processor have to switch mode between, sorry, when the user want to execute operation require supervisor mode. So all these things, if you use the Linux or Ubuntu, is more easy, right? You see. So in Windows, um, either you have administrator or you have user. But in the command line prompt, do you easily can see it? Yeah. So how? So control invocations, invocation of function that execute privileged instructions to provide limited or well-defined functionality and then return to the user mode. So um, if it's in the Ubuntu, yeah, we can say you're doing something called sudo. Yeah, you sudo, you do something, then you return back to the user mode. Correct? Sudo, I still remember sudo. Something like that. Interrupt and the traps. So all these things are back to your diploma, I guess, some theories lah. Let's work together. CPU are equipped with mechanism to deal with interruptions in executions created by error. User application requires timer input from hardware, etc. The trap, so application generated interrupt to invoke OS functionality. CPU save current state and then execute interrupt handle in supervisor mode. Then and after that, afterwards, restore the state and return to the user mode. So something like this. That is a term. What is the term called? Allow interruption and not allow interruption. What is the that is a term? Yeah. Suddenly I cannot recall. Yeah. Uh, like your last in first out, like some of the what is that term already? Yeah, suddenly want to want to think about it, then cannot. Which one allow interruptions? Interrupt. Uh, it's okay. It's okay, but we can try to find out in terms of your memory management also got process management also got, yeah, which one can allow interrupt, which one cannot. So how they track and then switch and swap it back, because they want to give way to the more priority things. Yeah. First in, first out, definitely they're not, cannot lor. Who come first, who do lor. That's why I call first in, first out. Lesser overhead, simple mechanism. Remember that? A little bit? Trying to um let you figure figure out all these things back. Yeah. I don't know whether uh this is another of my uh another class. It's okay. Yeah, suddenly cannot think. Okay, it's okay, it's okay. Yeah. Processor also the same, and yeah. And then Intel x86 architecture. Yeah, x86 is what? Still remember the Windows Intel, 4 privilege level, kernel level, highest protection, definitely. OS level, OS device driver, privileged user processors, and then user processes. This is the architecture. Privilege level can only change by single CPU instruction, POPF, which must be executed at level 0. Procedures can only access object in their own ring or in the outer ring and can invoke subroutine only within own ring. Many OS use only 0 got kernel mode and 3 user mode. You remember? Yeah. System call, like your function call, but for the system usage. Assume a user application in ring 3. Ring 3 user processors are okay. Need a service from the OS. You want to print, yeah. You want to deal with something need the hardware, or you need it release some memory or do some things, yeah. So on say like open a file, yeah. Open a file from application, your application, the Java you write or the C++ you write or whatever website you write, you want to open a file. Open the file is on your local disk. So definitely you need the OS to talk to the hard disk. So on x86 architecture, older OS used the call gate, which are allowed to call OS function directly, but nowadays usually system call are used. They just issue a system call. Now I think they even have what API call. Yeah. So user mode, kernel mode, so 0 and 3. So when you want to say your application say open the file, so he talk to this system call go down to the kernel, yeah, to look for the where is the file located in the memory and so on, and then where is stop, and then you return back the address, yeah, the address want to open the file, put into the memory, and then the system call return the message to the user application, file has been opened, something like that. Yeah. Application call function of the system library say open. So system call lib function ensure arguments are passed properly and then switch to the kernel mode to execute the system call. Call is executed via finding function in the system call table. Call return will trigger the switch back to the user mode and then deliver the result. Yeah. So this is a link that you can click and then you can try to refer back. So Stack Overflow, this is something I like. Okay, the teacher also using here. So copy from here. So what is this? C, C plus or C? C, in like this. But also depend on your programmer teachers, your programming teacher. What kind of the programming you did so far in your diploma or in your degree. In my own experience, we just do a very simple, which is touching the OS, basically like open file, print a file, store, that's all. Then the rest are all within user processes. Yeah, user within the application itself. That's all I can recall lah. Okay, so confused deputy problem deputy, yeah, your second man. Outer ring process may ask inner ring procedure to copy inner ring object to outer ring. So imagine the process or the program that compile other program, compile service. User can submit the code input lah and the executable file name output. So compile service log building info on the file called build. Examples only. So now user Bob requests the compilation of the program with output the build. Kaboom. So the user requests compilation of the program with the output build. Bob, of course, is using the application, yeah, to request upload this. So you need to, so how to resolve these confusions? So you need to bundle the designation of the object, such as the file and the permission, we call it capability. So here Bob should not have permission to build txt. So compile service should reject his request. Don't let Bob having so many access. Yeah? Capable deputy or capability deputy. Capability define process threats, treats permission that are verified prior or during the execution system call. On the Linux authorization based on the user running process threat, effective UID, GID plus user permission of the objects application capability. For privileged process threats, yeah, EUID equal to 0, system do not check authorization. Application capability define additional special permission for process thread. For example, in the Linux, this is the name lah. Capability net user role allow use of the raw socket for non-privileged user. So implementation depend on OS. Depend what OS, then use what architecture. So in the Linux or Ubuntu, this all see clearly, can see more clearly. Memory protection to allow what to prevent the buffer overflow, basically. Yeah. Logical separations of user to prevent accidental and intentation interfacing between the interference, yeah, between the user. Your file management dealing with logical memory object, your memory management dealing with physical memory object. File management dealing with something logical. Your hard disk, whatever things is in the logical addresses. Memory management, you are dealing with the physical, but actually it's still logical, but yet is referring to the physical memory object, your RAM. Yeah, and so on. Structuring memory, two ways, segmentation and paging. This one also in your diploma, I believe your teacher got mentioned to you. And of course, in your PIT, your degree got mentioned a little bit, maybe. Yeah, for your senior, they would study this again in the computer security lah. But for you, you're trying to pick up that, yeah, at least on the theory level. Segmentation, divide the data into logical unit. Segment have a variable length. Paging, divide memory into pages of equal size. Okay, not ideal for access control. Segmentation used for file management, but for memory, we use paging this day. You know how to find, right? Your paging. Yeah. So I believe you still can advanced system setting, I believe here. Yeah. I think here, oops, advanced paging. Yeah, if you still remember. But we didn't change much lah. We just use, yeah, we just use the default. All right. So memory protection continue. So with the segmentation, we have permission for the segment, file permission for file management, DPL, descriptor privilege level for memory segment. Segment can be accessed if current privilege level, CLP, greater than the DLP, descriptor privilege level, outdated approach. So CLP, current privilege level, must greater than descriptor privilege level. With the paging, we have page table that map pages to physical memory, your RAM. Yeah, this one is just virtual memory. If you still remember, your virtual map to the physical memory. So each process has its own page table. Unlocated page and pages allocated to other application do not have any address from the process point of view. To canal, we check access permissions on the pointers and addresses supplied by process to system call. Okay. Wow, so many things. So this one you imagine the table. Yeah, the table there, the table like just now I draw for you. No, not I mean I prepare for the diploma students. Yeah. Something like this, paging, yeah. So logical, physical, this is logical, meaning all the addresses. Then you need to have a page table. Yeah, page table is equal size, and then how to map to the physical memory. Yeah, some can allow variable sizes, some cannot. Yeah, remember, so still terminology, a lot. Important security principles: defend in depth, diversity of defend, implicit deny, least privilege, separation of duties, no security through obscurity, avoid unnecessary complexity, and don't forget your user. Let's go one by one. Okay, defend in depth. Defend in depth refer to the security practice of implementing several layers of the protection. The re, mi, fa, so, fa, everything's lah. So you can't simply take one single action, such as implementing firewall or installing antivirus for where considering yourself protected. Okay. But remember earlier we mentioned balance it, and then what is your object, business objective? Business come first, then only you talk about defense in depth. Yeah, build the house first, then only you put in your CCTV. Remember we talk about that, then you also laughing. Yeah, so security is just like a topping. When you eat ice cream, the topping. Yeah, build whatever you want to do first. Your business come first. Then only we talk about this security. You must implement security at different or several different layers. Okay. Like this. This is China war, is it? I don't know. Multiple countermeasures are taken to protect information access. Yeah, strategic are based on the principle that it's harder to beat multi-layer defense system than to penetrate single barrier. Agree? Yeah. You need to have more, just like the Chinese, the one say what you need to put a lot of the chopstick that you cannot bend. If it's just one chopstick, it's easy to break. So when they apply into the security, also something like that, put more and more and more and more and more and more layer. So outside will be your policy, procedure awareness. Then you have a physical security. Then you have perimeter security, internal network security, your host, your application, and then lastly your data. Okay, this is coming from this link, so you can click and then you read lah. Okay, so even though it's a bit it's okay one, can read one, it won't outdated one. Yeah, so line by line, detail by details. Yeah, go read yourself. My head. Diversity of defense, complement defense in depth, make different layer dissimilar, use product from different vendor. Wow, so how many money I need to put in? Yeah, and I think I told you all these things are not $100 or a few $1,000. This is all $1,000,000. Yeah, reduce chances of the common bug or misconfiguration of which allow exploit. Beware of this complexity. It's good to have, but it's not necessary to have. At the end, you still need to have your profit, right, for your business. Yeah, you can't spend too much money into security without getting benefit or revenue from your business. So beware. Yeah, beware of all this complexity. Implicit deny. So implicit deny indicate that unless something is explicitly allowed, everything is denied. Make sense? Just like your firewall. Deny everything first. Then whoever need access, you open one by one manually. Router and firewall often have access control list (ACL) that explicitly identify allowed traffic. If traffic does not meet any explicit rule, the traffic is blocked. Okay, make sense? Yes. We tutup semua. When you need, only I open one. Then if I want to troubleshoot, also I know which one to troubleshoot. More easy. So firewall configured to allow HTTP or HTTPS traffic on port 80 and 443 respectively would have explicit rule define allow this traffic to server. So with no other rules, all other traffic would be implicitly denied. Yeah, for example, any SMTP traffic sent to this web server on port 25 would be implicitly denied. If you need, raise the ticket, yeah, get your boss sign, then only the administrator will open it into the firewall console, whatever, whitelist your traffic if you need this. Justify first. I have your signature, I have your document, And then whatever I set into the firewall console or whatever, so I know, can track. So same idea apply for all the file and the folder permission. So for example, in NTFX, you can grant permissions such as full control, read, and modify. If Sally is granted full control permission to the file name project and she's the only person granted permission, then she would have the full control. What permission does Bob have? So since Bob is not explicitly granted any permission, he is implicitly denying all the access to the file. When come to the corporate, it will have this more clearly. Who can read what file? Like for example, your OneDrive, yeah, your SharePoint also can show you. You don't have access. If you need access, you fill up this thing, then press submit. Then the owner will review. Okay. Least privilege, I think I mentioned this many times in several subjects. So principle of least privilege or least authority, subject must be able to access information and resources required for legitimate purposes. For example, user account check for the sole purpose of creating backup should not be able to do other things such as installing software. In cases where some occasional evaluated permission are required, it is best to grant specific temporarily elevated privilege rather than blanket access to higher privilege. Okay, this one can clearly demonstrated in the Linux Ubuntu, the sudo lah. When you need, you use sudo. So am I getting root access? No, ROOT, no. I'm still the user, but if I need, I use sudo. But in Windows, I don't think so, because such thing, either you have administrator account or user account. So now you know which one is more easy being attacked. Okay. For example, Nina, we use sudo. Okay. So separation of the duties. Again, this least privilege, this separation of duty, all these things are referring to the mature and MNC type of the company size. If your team just 2%, can you do this? Yeah. Think about SME. Yeah. If the whole team, like for instance, our company, only one cybersecurity manager, right? So how to do this thing? Yeah. So depend on the size of your company. Yeah, applicable to the physical network and the host security for any given task, more than one individual needs to be involved. As you know from the movie, need different key to launch nuclear warhead. Two key can they turn it, yeah, something like that. Tasks broken into the different TT, each of which separate individual is responsible for. No single individual can abuse system, but approach may increase the cost, the time. Okay, so separation of duty. Big company can, small company, one man under the sun. And then need you do more also. So you can't separate the duty. No security through obscurity. So any security measure that relying on the hidden or obscuring technology detail from others are security by obscurity. The analogy from the Bruce Nair, yeah, this guy again, Bruce Nair, very important guy. If you don't know him, just go to Google. It's not Bruce Lee, Bruce Nair. He's a American computer researcher or scientist. He wrote a lot of the books. I also referring some of his books. If I take a letter, lock it in the safe, hide in the safe somewhere in the New York, then tell you to read the letter, this is not the security. This is obscurity, meaning he make the thing complicated. Itu saja. On the other hand, if I take the letter, lock it in the safe, and then give you the safe along with the design specification of the safe and 100 identical safe, so that you and the world best safe cracker can study the locking mechanism, and yet you still cannot open the safe, that's called security. Okay, meaning I tell you the mechanism, I tell you what I'm doing, but yet you still cannot break me, then that's called security. Attacker can often discover the obscure detail, but not obscurity is not beneficial. Defenders are often hindered by abstract details, and then there is much greater risk and cost that assumed. Possible to build secure system without obscurity. You don't hide it. You tell people, yet you still cannot hack me. So this is called security. Okay, can you imagine this? Can I think can. Avoid unnecessary complexity. So unnecessary complexity could lead to weaknesses if mechanism or system is not correctly understood, modeled, configured, implemented, or used. Security mechanism should not be more complex than required. Simple, but yet the hacker cannot do anything about it. Yeah? Avoid unnecessary complexity. What's the purpose? You make yourself so stressed, like you put a padlock, then CCTV, then the movement detector, and so many things, so people don't come to your house. But then when you want you yourself go home, you need to disarm this, disarm that, disarm this, disarm that, open so many padlock. Do you think it's over complexity? Yeah, balance it. Don't forget the user, all right? User are most important component of your security system, but can also is the weakest link. Okay, you know already, you put a million project, but you put a dumb there, or the person who lacking of this awareness, or just careless, human error or people falling victim to social engineering, phishing are often root cause of the security breach. User need to have security awareness or training. When you design secure system, you also need to keep human behavior and usability in mind, or otherwise you will end up a less secure system. You build a very high-end security thing, but then it's too complicated for user to follow or to use, so it's a disaster. So it's stress, right? I know. Forcing your user to forcing your user to remember very long and complex password will probably causing someone to write down their password. Yeah, make sense? Okay. So lecture summary and the week ahead. So terminology, aspect of the security, design principles, secure the system and its component. Yeah, and this is the one, okay, reference monitor, the trusted base component. What TSB or something like that. And then important security principles. Inside the lab, you need to installation of the virtual software environment used for the lab. Make sure you bring the USB hard disk or USB stick, that medium for your VM. Yeah, so many. But now, this is, I think, referring to OLA. Now is the Microsoft Azure. Yeah, next week is the access control. Okay, so I'm going to stop for here. Then later I will come back again with the lab activity, the short one. Hopefully you can follow. All right, so let me just click here. Okay, I stop recording.